Okay, so today is October 28th, it's Monday, and today we're looking at adding and subtracting rational algebraic expressions. This gives us a chance to review what the word rational means. You'll recall from our previous study that a rational number is any number that can be written as a fraction. So another title for this could be algebraic fractions. I have a review problem for us to start. You can see there's no algebra in it. But if we can do this problem with numbers, then we can handle algebraic fractions. So let's take a minute to review how we add two fractions. First, anytime you add or subtract fractions, you should think, I need a common denominator. So what's a common denominator of 6 and 9? 6 and 9, 18 it would be. In order to get 18, you have to multiply this first fraction by 2 over 2. And the second fraction, oh no, not 2 over 2, goodness gracious, sorry. To get 18, you have to multiply the first fraction by 3 over 3, and the second one by 2 over 2. So then we can see that 5 sixths is equivalent to 15 eighteenths, and 2 ninths is equivalent to 4 eighteenths. So the first thing we did was get fractions with common denominators. We always do that when we add or subtract fractions, whether they're regular fractions or algebraic fractions. Once we have our common denominators, you should know by now that you actually just then add the numerators. 15 plus 4 gives us 19 eighteenths. So step 2 is to add the numerators, and you keep the denominator. Now, 19 eighteenths is a fraction that's improper, so we know, and most students would say, well, we should change that to 1 and 1/18. So a third step is to simplify your final fraction if needed. Now, some of them today, most of them today, you won't have to do that with, but that's good practice. All right, so keep that in mind. Those are the same steps we use as we work with algebraic fractions. Here's our first algebraic fraction. We have 2x over 5 plus 1/3. So step 1 is to get fractions with common denominators. Well, a common denominator of fifths and thirds are 15ths. So we want to multiply the first fraction by 3 over 3. And the second fraction by 5 over 5. It's a good point to emphasize that I really focus on we're multiplying it by 3 over 3. Because really that's equivalent to just 1. When we multiply anything by 1, we don't change its value. We're just looking at a different form of the same number. So our fractions with common denominators are 6x 15ths plus 5 15ths. So that was step 1. We got our fractions with common denominators. Step 2 is to add the numerators. Well, 6x and 5 are unlike terms, so we really can't do too much except write it as 6x plus 5 over 15. That's it, and we're finished. That's our final answer. I caution you that often beginning algebra students will look at this final fraction here, look at the 5 and 15 and think they can cancel them, but you can't do that. Keep in mind that what we cancel in a fraction is a common factor, and this 5 here isn't actually a factor, it's part of a sum, it's not part of a product. So we can't cancel it. This numerator represents some unknown number, and you can't cancel out of just a piece of the expression representing that number. So this is it, nothing else to do, we can't cancel anything there. All right, let's look at our next example. It gets a little bit more interesting. Now we have 2x minus 3 over 5 plus x minus 3 over 3. All right, well, stick with the steps. Step 1 is to get a common denominator, fractions. Here kids want to start to take shortcuts, and I really discourage that. I recommend you model doing this the same way that I model it. Fifths and thirds, what's a common denominator? Oh, 15ths again, yep. So it's similar to the other problem, it's just the numerators are more complicated. So in order to change my fifths to 15ths, I have to multiply the first fraction by 3 over 3. Now watch carefully. This first fraction has 2 pieces in the numerator, and I'm going to have to multiply both pieces by 3, so I got to put it in parentheses. These parentheses are key. You must use them. Plus, to change my thirds into 15ths, I have to multiply by 5 over 5. And again, make sure you put your numerator in parentheses, because you got to multiply that 5 by both parts of that numerator. All right, so now we know that we have our common denominator of 15th in both fractions, so we can write this all as 15ths. All right, here we got to multiply our 3 through both parts of that numerator. So 3 times 2x is 6x, and 3 times negative 3 is negative 9. Don't forget to change those subtractions to equivalent addition so you don't lose your signs. And then continuing on, 5 times x is 5x, plus 5 times negative 3 is negative 15. So now we have it all together. We just have to simplify, combine any like terms that we have in our numerator. We've got a 6x and a 5x, so that simplifies to 11x. And we have negative 9 plus negative 15, so that's the same as plus a negative 24 15ths. Now remember that we want our answer simplified, so we're going to take a second and change this to 11x minus 24 over 15. This caution sign is here to remind us that, once again, don't be tempted to cancel a factor of 3 out of these two numbers, because this 24 is not part, it's not a factor, it's part of this whole sum. So you can't cancel unless it's part of a product. Here's the caution and how it's written. I include that in your notes. That's clear to see better. Never cancel a factor from only one term of an expression. So you can't cancel anything in this final answer because there's no factor throughout all parts of the expression in the numerator. Include that in your notes, okay? All right. We're going to continue on with one more example. And if you'll notice, both of these problems were addition problems. Now we're going to move on to a subtraction problem. Okay, so here it is, 2x minus 7 over 3 minus 2x minus 6 over 9. Well, step one, when you're working with fractions, is still set up your fractions for getting common denominators. Thirds and ninths have a common denominator of ninths. So the first fraction, I need to multiply by 3 over 3. And be really careful to put your numerator in parentheses, or you'll lose multiplying both parts of it. Now there's subtraction in here, but we're going to hold off a second to deal with that subtraction until we have set up the multiplication for common denominators. What do we need to multiply 9 by to get ninths? The students always say 1. Yes, 1 over 1. Let's write that in. There's lots of places where you can incur sign errors if you're not careful in a problem like this, where two algebraic fractions are being subtracted. If you follow these steps and now take care of the signs, you will be successful. So I'm subtracting a 7, I can change that into adding a negative 7. Here I'm subtracting this whole fraction, so I'm going to change that into adding negative 1 times it. And here the subtraction also can be changed to adding a negative. Again, we do this so that you don't make those beginning algebra sign errors. Now I know I've got my common denominator 9 here. Now I just need to work through my numerators and simplify. 3 times 2x is 6x. 3 times negative 7 is negative 21. Negative 1 times 2x is negative 2x. Negative 1 times negative 6 is positive 6. The second fraction is where kids will often make a sign error if they don't follow the steps, like I said, setting up for the common denominator, and then after that, changing the subtraction to adding the opposite, so you don't lose this sign right here that needs to get distributed through. Now I combine like terms. 6x plus negative 2x is 4x. Negative 21 plus 6 is negative 15 over 9. And one last thing you should notice is that this plus and negative needs to get rewritten back to just straight subtraction. Final answer is 4x minus 15 over 9. So your homework problems are very similar to this, and they're in the textbook, so you can check your answers as you go in the back of the book. Make sure you do that so you know if you're doing the problems correctly or not. I hope that you feel better, and we will see you soon.